So using my work from the above part, I had the actual area, which was 900, and I had the estimated error, which was 10.75. So now if I want to calculate the relative error, I'm going to take that estimated error over the actual area, and so I'll have 10.75 over 900, which is 0.0119, and if I turn that into a percentage, I get 1.19%. So I think these next three examples are probably a better use of how you are going to use differentials. So let's say I want to approximate the square root of 16.5. And so I say, all right, then I know that my y values are determined by square rooting some value that I plug in. I was hoping that I could plug in something that I knew the square root of, but 16.5 clearly I don't. But what I could say is, ooh, I do know the nearest number, which is square root of 16. And then the amount of change, I could call it delta x or h, would be 0.5. So the amount I've moved away from x is 0.5. And so, therefore, x plus delta x, or rather f of x plus h, we talked about yesterday, which is my old x value plus the amount I moved away times the slope, because I'm using the tangent line to generate this estimated value. So now I know x and I know h, but I still need to know what's f prime of x will look like. So I will come back over to here and find f prime, which of course is 1/2 x to the negative 1/2, or 1 over 2 squared of x. And so now I'm ready to start plugging some things in. So I'm doing f of 16 plus 0.5, which would be f of 16 plus h, which I happen to know h is 0.5, times f prime of 16. And so I know f of 16, well, f of 16 I can do in my head, right? That was kind of the whole purpose. So that'll be square root of 16, which is 4. And the slope at 16, well, I can come down here and get that, would be 1 over 2 square root of 16, which will be 1/8. And then when I do all my math magic on that, I get 4 plus 1/16, because remember I'm really taking half of an eighth, which is 65/16 for the people who like fractions, and as a decimal, it's 4.0625. Let's try another one. So on this next one, I'm cube rooting, and I don't happen to know the cube root of 27.02 off the top of my head, but I do happen to know a value that's very close. So we're going to say that this is the cube root function, and that x is 27, and the amount I'm moving away from x is 0.02. I'll call that h. And so now I know that f of x plus h is this formula. And so in order to substitute in, I would be finding f of 27 plus 0.02, which is f of 27 plus h, which is 0.02, times f prime of 27. So now I have to, of course, figure out what's f of 27, but that was the whole idea, was that I already knew that much was, of course, 3, so I'd be substituting in 3.